Basically, if the distance is like it should be like it's the thing that's right here.
What makes you feel better? I messed it up. Not that that's the so far. No.
All right, let's take the simplest possible thing to reflect. I think in my hand gestures, I motioned that it was going to be up like above the x-axis. So let's do it up here. Let's take the point -2, 2, just a single point, the most basic thing. Then we can do triangles and rectangles and all those things. All right, single point. It's called A, and we're going to reflect it over the x-axis. Who's confident with what the new rule is going to be? I saw Preston stand first.
So you're going to keep the x value the same, and then you're going to multiply the y value by -1 flip it to the other side.
Okay. So we'll call this A prime. So what would the new point be? -2, -2. So you take, in this one, we took the xy. You said keep the x the same. So the rule is going to be keep the x the same. And then you said opposite y. Make sense? If it was up at +2, now it's at -2. If it was down at -10, now it's up at +10. Opposite. Same x, opposite y. Olivia.
Are we writing that in the box?
I would. Be a good notes to guide you through. What about a y-axis reflection? Here's the y-axis. Take any xy. Now we're going to generalize it. I'm not going to even name it. I don't care what its name is. We're going to take xy. Page.
-x, same y.
-x, same y. So here's the y value. It's going to be the opposite x. So it was over from the y-axis 1, 2, 3, 4, 5. In general, x. Now it's -1, 2, 3, 4, 5. -x. Same y. Make sense? So if I were to just put these up on the board, some students would be like, oh man, that's weird. Why? What are you doing there? But if you think about it, it's easy to figure out, isn't it? Isn't that easy to figure out? So sometimes rules are good. You can just memorize them. Sometimes it's easy enough to figure out. It's like, one less thing to memorize. So either way, it's important to be able to do both. All right, and then the next question was, is a reflection, I kind of covered it up with these boxes. Is a reflection a rigid motion? Remember yesterday, a rigid motion is some transformation that doesn't change the shape or size of the object. Okay, now this was just a point. But what if you were to take a triangle and reflect it over the y-axis? Would it change the shape? And by shape, I don't mean like change from a triangle to a rectangle. I mean like change its appearance, right? Same shape, same size, right? Rigid motion, still a rigid motion. All right. So a reflection is a transformation that uses a line, like a mirror, to reflect a figure. So we have what's called a line of reflection. Now, there's some terms in here. I don't love the way this book words it, and we'll talk about how the old book words it, how the new book words it, and then we'll talk about, I guess, not really preference, because it doesn't matter. We might be asked either way. So we need to kind of be comfortable with both. All right. Now, I think it makes sense. We're not going to actually construct these by hand, but if this is your line of reflection, can you at least accept, I'm not going to do this, but do you accept that if you take a point and reflect it over that line, not the x-axis, not the y-axis, just some random line, that you would have to envision it being on the perpendicular line that goes through the line of reflection. Does it make sense? So if I'm here and I reflect this line, it's not going to end up down here. It's going to be perpendicular to that, or down like this, perpendicular to that line. So that's why we had to learn all that stuff about, perpendicular lines and bisectors and so forth.
Are we going to be doing proofs with these?
No. This is the language that I wasn't really loving when I read it for the first time. So triangle ABC and its image after the reflection described. It says in the line M, y equals 1. Okay. And so, you're right over there.
Yeah.
All right. So first thing on your guided notes is this one.
What are we supposed to put in the
Awesome.
boxes?
Oh, yep. We didn't do it over the line y equals x.
Oh.
Over the line y equals negative x.
Yeah.
We're going to come to those in just a minute. I want to focus on these ones first. Okay. Let's do these ones first. So go ahead and graph ABC. Everybody go ahead and graph ABC.
Oh, it's right there.
So nice. So nice. All right. So as we do this, the old book would say about the line or across the line. Okay. And so if we have y equals 1, go ahead and graph y equals 1. This is your x-axis. And this is your y-axis. Is the line y equals 1 horizontal or vertical? Horizontal? Vertical. Ooh, that's some different opinions in here.
It is this way.
Y equals 1. Horizontal? Vertical. Who votes horizontal? Who votes vertical?
Well, if y is 41, then y has to be 1.
Okay.
That could be x. So
Here's another thing that it helps to not have to memorize.
I actually horizontal.
If you say y is 1, give me some points that have a y value of 1. Start giving me points that have a y. Anyone? 2, 1. I heard 2, 1. What else? 3, 1. 1, 1.
I literally so you. Okay, well you didn't raise your hand for
Negative 10,
Yeah, because no one else did.
1.
Everybody over
So we're not the smartest fit.
So guys, again, more rules. Oh, well, I remember back last year we were told if it's, y equals, then it's going to be horizontal, or x equals, it's vertical. Just think, if y is always equal to 1, what kind of line is that? Oh, y 3, 1, 4, 1, 10, 1. That's the line y equals 1. Okay? So I have to graph it. You guys already have done it. You're just right. 1, 2, 3. Okay. 1, 3. B is 1, 2, 3, 4, 5. 1, 2. And C is 2, 1. All right. If we're going to reflect this, not over the x-axis, not over the y-axis, over the line y equals 1, can you envision this triangle being reflected? Yes? Awesome. Let's write the new points. First of all, what's C going to be? The same, right? It's on the line of reflection. C prime will be the same. Now, here's the deal. You have to realize the rule, because it's not the x-axis, it's not the y-axis. You have to recognize what's the rule to reflect it over another line. Well, didn't we just talk about it? It's going to have to be, if this is our line of reflection, whatever this distance is to P, it's going to be the same distance to P prime. Do you see those tick marks? So if you use that idea, how far above this red line is A? 2. So A prime is going to be 2 below, right? 1, 2. A prime. And C was 0 above and below. It's on it. So C prime is going to be on it. B is 1 above, so B prime is going to be 1 below. And there's your reflected triangle. And again, give it the eyeball test. Does it look like it's been reflected over that line? Yeah. Should not change shape. Should not change size. All right, try the next one quickly. And you should know what x equals 3 looks like. Did you get something that looks like that?
Yeah.
Kind of weird. I kind of picture like, of course, the food enjoyer in me pictures like the line of reflection, kind of like a rotisserie, when it's right on it, like sticking it through like a nice, delicious, whatever you want to cook over a fire. Maybe a marshmallow. And then you kind of spin it on that. You know what a rotisserie is?
Yeah.
And then you kind of spin it, and you see how it's kind of like turning it that way, right? Flexing it. Maybe it's a bad analogy. I'm trying to think of food though. Make sense? Again, we're not using rules of reflection. We're not using x-axis, y-axis reflection. All right, now we're going to need to figure out what's the y equals x rule. We'll go back to our beginning of our guided notes. So we're going to kind of develop the rule together. Here we go. First of all, you have to know what the line y equals x looks like from last year. Y equals x. If we're going to graph that line, that's our line of reflection. We actually have to graph it together, don't we? Unless it's graphed for you. Oh, you don't have this one? Okay. Yeah. You might want to take a few notes on this in like the columns on the side. Just if you want to write it under the y equals x rule, you can. That's fine. What does the line y equals x look like? Well, what's its slope? And what's its y-intercept? What's its slope? I heard someone say it. 1. What's its y-intercept? It's y equals mx plus b. You surely remember that, right? Used that a lot last year. Y equals mx plus b. Please be honest with me. Yes? Y equals mx plus b.
Yes.
M is the slope. B is the y-intercept. Well, there's no b there. It's not like plus 2, plus 5, plus 10. So b is 0. So the y-intercept is 0, 0. 0, 0. My slope is 1. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. That's the line y equals x. You're going to find that popping up in math a lot over the years. Y equals x. Y equals x. Okay, well, if we graph this, we're going to kind of make our own rule. -1, 2. is -1, 2. G is 1, 2. And it's just a segment, FG. Now, we kind of have to blend a couple ideas here. One, do you all see where F prime is going to be? If this is your line of reflection, isn't F going to be on the perpendicular line over here? Can you envision that? Please be honest. Can you envision this imaginary perpendicular line that goes to the line of reflection? Can you imagine it? And then can you imagine whatever this distance is here, F prime is going to be the same distance over here. So how do we make that rule? This xy, what do you think? What do you think? Talk about it for a minute. Try to figure out. This is the honors part of this class. Try to figure out the rule.
Well, isn't it the thing where you flip it over and then you reverse?
I have no idea what that one thing is. Be more specific.
Since it's 1, 2, would you make it 2, 1, and then make it -2? For like shapes, would that be the point? -2, -1? Because you're flipping it upside down, and then you're like turning it around.
I don't know. I don't remember my algebra class.
We learned that like 2 seconds ago.
I was dead.
Wait, so like making it 2, 1. Forget about it. No, wait, don't forget about it. Yeah, 2, 1. Because is it down?
My head.
And then it,
All right, even if you don't know the rule, do you know the point where it's going to be, where F prime is going to be? Who thinks they know? Right? What do you think?
1, -2.
1, -2 is right here.
Were you?
So either my purple line is off, or we need to keep talking. Did anybody else get 1, -2? It's okay. Appreciate that. Nobody else is raising their hand. Anybody have something else they think? Olivia?
Wait, wouldn't the X stay the same? Because we just said that.
Well, that was for x-axis reflection.
Well, I'm confused on why it's like going down instead of just over.
I'm not sure what you mean.
Like it's like going like diagonal instead of just like a.
Because it's a new line. We're not reflecting over the x-axis or y-axis. We're reflecting over this red line. That's like our new mirror. They told us. Reflection over the line, y equals x. And they use the word in. I hate that. And it's image after a reflection in the line y equals x, or a reflection in the x-axis, a reflection in the y-axis. I prefer to say reflection over the x-axis, or over the line y equals x. Okay, Christiana? 2, -1. Let's see. 2, -1. That looks better. Let's see. 2, -1. And then, Christiana, did you get as far as thinking about what G would be? Not yet? Let's work together. I hear 2, 1. Let's see if it looks right.
Oh, maybe it does. -1, -2. Is it supposed to look like that?
Think about it.
no, wait, no, I wasn't.
Would this look like that if it gets reflected over that line? Can you see it?
Yeah, you're just switching X and Y.
Listen, you guys were really good. Stop. You guys were really good with x-axis, weren't you? Do you know how you can see if this looks about right? Because when I said over the x-axis, you're like, oh yeah, down here. Just turn your head like that. Pretend that red line's the x-axis. Does it look right? You're turning your head the wrong way. Turn your head so this looks like the x-axis.
Yeah, it looks good.
Do you see what I'm talking
I
about?
mean, it makes sense. It's just like, wait, so the line, yeah. Or the second.
Guys, listen. You're overthinking it. If watch up here. Go ahead, Emma. Ask a question. Go for it.
I don't graph. I don't get this.
It's okay.
Why is it turning? What is it just? I understand that it's turning like that.
Hey guys, you're gonna be asked to do a couple things. Watch up here. This is a different problem, but when I said reflect this over the x-axis, you would have taken this line. Ignore the red line, please. Ignore the red line for now. If I said reflect FG over the x-axis, you would literally just drop it down here, wouldn't you? Why? Because whatever distance it is above it, when you reflect it, it's going to be the same below it. Now, ignore the x-axis and the y-axis. Take your eyes and ignore the black lines. Only look at the red ones. Okay? Do you see F? Can you, if you reflect it over, pretend this is your new x-axis. If you reflect this over, wouldn't it be down here? Okay? Girls, please ask a question. Let's try to stay together as a class. If you're confused, ask. Can you all for a minute pretend this red line, if it were the x-axis, can you pretend? That's why I said turn your head. Can you pretend this is the x-axis for just a second? Because they told us to reflect it over that line. We didn't get to just choose. We were told. Right? Wouldn't it be over here? Wouldn't you drop this across that line? Do you see it? Okay, but we have to make a rule for it. So our -1, 2, I'll get your question in just a second. Our x and y turned into what? Well, this is -1, 2. What was f prime? 2, -1. Okay? And if you didn't figure that out, it's okay. We're making a rule together. What did we do to get from x, y? Switch them. Not sign, not positive, negative. The physical position of x and y, didn't we? So what is it now? Y, comma, x. What was once the y is now the x, and what was once the x was now the y for the new one. This is the rule for y equals x reflection. This is the rule for y equals x reflection. This is Matt. Hello. I do. Sure. Olivia and Mr. Cole, I would like to see your name here. All right. So on your front page where it says y equals x reflection, you should put x comma y turns into yx in that box. Let's put it there too. Yep, there's a box for it. Where it says y equals x reflection. This is the line y equals x. We're reflecting over that line. xy turns into yx. Tally question.
I was going to ask you if that is what it was.
That is the rule. This is the rule. Y equals x reflection. Why would they pick that one? Well, I don't want to get into too in depth to it now, but in Algebra 2 and pre-calculus, there are certain types of functions that are reflections of each other over the line y equals x. All right? And that'll be important to know what that looks like. And so this is a good little precursor for it. Okay? Now, we'll get into y equals negative. Do you guys want to just write down the one for y equals negative x now to finish it off? All right. x, y. So y equals negative x reflection. X, y turns into negative y, negative x. X, y turns into negative y, comma, negative x. And we've developed all the other ones. We don't have time to develop that one right now. Okay. Do you at least know what the line y equals negative x looks like? You have to know what the line, if you can't graph that line, you're not going to be able to reflect over that line. The line y equals negative x it would have the same y-intercept, it would have a slope of negative 1 instead of positive 1. So it's going to be that line right there. Okay? So now you're taking this blue segment and you're reflecting it over that black line. Can you see it? Okay. Oops, I even dropped a little line there. The book uses A and B for X and Y. Okay, I prefer X and Y, so if you see the difference there, I prefer X and Y because you think, okay, X is the X value, Y is the Y value. They use A and B. Same rules as we did, just with the letters A and B instead. All right. Is this one on your guided notes? Y equals negative X reflection? No? Okay, we'll skip ahead then. That's just using a rule. We need to keep moving. All this is saying is if you take a triangle and you reflect it over a line, all the sides and angles are going to stay congruent, aren't they? It's going to be it's called a rigid motion. It does not change the side or shape of it. And by shape, I mean it doesn't change its angles. All right, a glide reflection is a transformation involving a translation followed by a reflection. A translation, ooh, that's yesterday. What's the translation? Slide, 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 a move, a shift. Okay, followed by a reflection. So all you would have to do there, if you're given ABC and you're asked to translate it and then reflect it, do the plus whatever and minus whatever first, the translation part, and then take those new points and use the rule for the reflection that they ask you to do. Make sense? Okay, you just literally do 2 of them. All right, so here is the example for this. You have the x minus 12 one? Yeah. Awesome. All right, so we're going to graph, and we're going to run out of time. Let me walk you through this, okay? You need to know how to do this. Yes, Jackson?
For the translation and then the reflection, would it be called P prime to P prime prime?
Double prime, yep.
Double prime.
Yep. So A, that's a good note. Ready? Here's what I'd like for you to do. A is 3, 2. You're going to move it left 12, so now it's going to be negative 9. 3 minus 12 is negative 9. Same y, so the y value is still 2. I'm just doing point A. Are you with me? All eyes up here. 3, 2. The translation will make it negative 9, comma 2. Call it A prime. Then you're going to reflect it over the x-axis. So negative 9, comma 2 over the x-axis is now negative 9, comma negative 2. That's A double prime. A double prime. So there's an A prime to do the translation. There's an A double prime to do the reflection. Does that make sense? That's all you would do. For B, watch up here. What's 6 minus 12? Negative 6. Same y. 3. Negative 6, 3. Reflected over the x-axis. Negative 6, negative 3. That's B double prime. All right? Tally.
So to write the double prime thing, you put 2 across.
2 dashes. Yep.
Getting math. I was done for it. No, it's not wrong. What I did is not wrong. I can tell.
All right, the homework's up on the board. It's on Google Slides as well.
That's the point. Suffer. I would like to deny all claims, and I'm not going to take this present on my winner.
You're gonna love the outside, by the way.
Yeah, definitely.
Mr. Parker, hello.
At least the Lego part.
Oh, Lego.
Yeah. That's
How you doing, guys? Well, I don't know if I'm ready to see some of you guys like your ass. Yeah, Lynn, I'm talking to you. Just kidding, nicely.
Go on, man. You can't be tired. Do you remember Matthew?
Yes, when I went to prom center, I was confused on 2 pounds.
Yeah, so. I got confused with that. Just looked at my notes.
Wait, which one did I
No. Just serious question. See, just see my answer. Class.
Free of the shot. I just realized something.
I should be like teaching you guys.
I did. Dang it.
Dang it.
So,
Oh, you just didn't do it. Good. This is how I do it. Is it like this? I made it different. I make it fun. I make it fun. Hey, I get him off topic, so he just talks about movies on there.
I got everything but my
2, 4, 6. Oops.
Who's out here? Say aye.
It's like right here.
Matthew's absent. Here, Mr. Westfall.
That's good,